All right, everyone, it is 10 to the hour and we are live, so let's get started. Just a quick reminder before I introduce our next speaker to check out our sponsor booth, which you can navigate to with the booth icon to your left. Check it out for a chance to win some great prizes, including Amazon gift cards and a custom pair of Nikes. Now, without further ado, I'd like to introduce our next speaker, Alessya Visnjic. Alessya is the CEO and co-founder of WhyLabs, the AI observability company on a mission to build the interface between AI and human operators. Prior to WhyLab, Alessya was the CTO in residence at the Allen Institute for AI, where she evaluated commercial potential for the latest advancements in AI research. Earlier in her career, Alessya spent 9 years at Amazon leading machine learning adoption and tooling efforts. She was a founding member of Amazon's first ML research center in Berlin, Germany. Alessya is also the founder of R-Square AI, a global community of thousands of AI practitioners who are committed to making AI technology robust and responsible. She will be giving us a talk about the critical missing component in the production ML stack. Please give a warm welcome to Alessya.
Thank you, Peter. It's fantastic to be here. Hello, everybody. Thank you for joining Machine Learning in Production in the Bay Area. Thank you, MLOps group, for organizing this. All right, as Peter said, my name is Alessya Visnjic. I am the CEO at WhyLabs, the AI observability company, and today I would like to present an open source project that fills a huge current gap in the production machine learning stack. Here's what I would like to cover in the next 30 minutes. We'll start with looking at the machine learning stack and discuss what's missing. Spoiler alert, there are many things missing from the production machine learning stack. You've already heard a talk about observability being one of the missing components. Today, I would like to focus on what I believe is the most critical missing component. It's a very basic and simple one. It's data logging. I'll present ideas on how to design a logging solution specifically for machine learning. And I will present an open source library that implements these designs and show you how it works in a live demo. It's going to be the most spicy part of my talk. We'll conclude this with a Q&A. Let's go. All right, so machine learning applications are delightful when they work and dreadful when they don't work. If you're supporting a machine learning application or supported one at some point, you probably have a story or two or three about how it failed and upset your customers. Just like Andreas here, who is, as of recently, a celebrity because he has encountered a really frustrating behavior with the Whole Foods algorithm, which recommended him a pepper as a substitute for roses. It's a very harmless failure, but it could be a frustrating customer experience, frustrating enough for Andreas to tweet about it. What's worse is that debugging such a behavior is extremely frustrating and time-consuming. Just imagine what it takes for an AI practitioner on call to troubleshoot and figure out why this is happening. Since 2019, I've spoken to over 200 data science teams and mid-sized companies, large enterprises, AI-first startups, and so on. I wanted to understand what are the pain points that they're experiencing when they have models running in production. One of the questions that I've asked is to tell me about a recent failure that they have dealt with. And surprisingly, every single one practitioner that I've spoken to had a failure story and told it very passionately. So what you're seeing here on the slide is, believe it or not, just a tiny sample of problems and stories I collected over the years. Software engineers in the audience are likely to be noticing many issues that point at a bad CI/CD practice, or maybe the lack of it altogether. If you're operating a model in production, you're probably nodding right now because you have experienced some of those. Although if you're operating a model in production and you have not encountered any of these issues, I would love to talk to you, because either you have an incredible machine learning practice, or perhaps some of these problems are happening completely unnoticed. I'd love to learn. So typically when we're thinking about software failures, we turn to the DevOps tools. And unfortunately, DevOps toolchain alone won't solve the problem. That being said, it doesn't mean that you shouldn't lean on the DevOps toolchain to make sure that your code is running robustly. But DevOps tools for testing, validating, logging, and monitoring do not transfer well to machine learning systems. And the reason for that is because unlike traditional software, the machine learning applications can be derailed by small fluctuations in data alone. In the list of failures that I've collected, you see that the failures that are encountered by machine learning systems in production, majority of these failures are stemming from issues in the data. Now, thanks to big data platforms like Databricks, machine learning engineers are able to build pipelines that can process terabytes of data. And this is both a blessing and a curse. It's a blessing because we can now easily deploy applications that are extremely data hungry, extremely complex and sophisticated deep learning models and so on. But it's a curse because if you look at the 4 core steps in the machine learning stack, the processing of raw data, generating features, training the model, serving the model, and so on, each one of these steps involves transforming and moving massive amounts of data, in some cases in a live system in the streaming mode. When you operate such a stack in production, you quickly learn that each of these steps can introduce a data bug or can be completely derailed by a data bug. Machine learning models are very sensitive to data bugs and data changes. In fact, the majority of machine learning failures stem from data, from missing data, duplicate data, bad quality data, and data drifts. Unsurprisingly, we're now entering the era of data-centric AI, which is where everybody becomes aware of how important data is to machine learning systems. So now, if you're operating a model in production, your most common daily task becomes answering questions about its behavior and health. And these questions are often rooted in data. Again, you're asking yourself, how's my model performing? Is my model drifting? Some of these questions are simpler than others. However, each one typically involves figuring out what happened in the past to the model, which in turn involves pulling some data and processing it. Think back to the last time you debugged a poor performing machine learning application. You check the code, the model version, the infrastructure, only to realize that the problem is actually hiding in something that has to do with the data. So how do you debug it, test it, monitor it, document it, and so on? It's not a novel problem by any means. Every engineer who operates machine learning applications in production has their own improvised way of testing, monitoring, and debugging data. It's probably ad hoc. It likely involves pulling a lot of data from storage, writing complex ETL queries, processing the data, writing visualizations in your favorite notebook, and so on. It can be extremely tedious and very time-consuming. Now, imagine if instead of doing all of that, instead of running that tedious manual process, every time you need to investigate something about your model, instead there was a way to continuously log all of the key properties of data flowing through each stage of your machine learning stack. Then instead of running ad hoc notebooks that pull and process all of this data, all you have to do is look at the log file from yesterday or look at the log files that span a week of time. Isn't that a neat idea? Say we wanted to design such a data logging solution. What would it look like? What would it have to capture in order to provide most utility to AI practitioners? Well, in my experience, after working with dozens of machine learning teams, there are 5 core categories that are most crucial to track for understanding how good your data and your model is. One is tracking metadata. It allows you to understand what different subsets of your data are and where they're coming from and how fresh they are. Then you need to track counts because that allows you to ensure that the data volume is healthy and allows you to keep an eye on missing values. Then you need to track statistics because it allows you to identify outliers and pinpoint data quality bugs. Then also you need to track distributions to help you identify changes in the distribution and catch those annoying distribution drifts. And finally, you can also optionally track a small stratified sample of your raw data to help you with debugging, post-hoc exploratory analysis, and explainability. Okay, now since it's a logging solution and we're designing it, it's going to be part of every step in your machine learning pipeline. So we need to be thoughtful about its runtime, properties, and outputs. What are the key properties of a good and useful logging solution? Well, here we can turn to the DevOps best practice. A good logging solution should be lightweight. It should run in parallel with your main data workloads. Should be portable, which means that you should be able to plug it in anywhere in your pipeline. It should be configurable, which means you should be able to configure it to the needs and the use cases in your pipeline. And finally, since we're working with data statistics, it's really important for the logs to be mergeable, which means that you should be able to merge statistics from different instances or to aggregate it over time. Well, after many years of supporting these machine learning applications in production, my team and I at WhyLabs set out to build a data logging solution that implements all of these properties. I'd like to introduce WhyLogs. It's a purpose-built machine learning logging library that is open sourced by our team at WhyLabs. WhyLogs is built to provide a lightweight, portable, configurable, and mergeable data logs for both batch and streaming data workloads. Check out the bit.ly link to get to the GitHub package. WhyLogs is already making lives of AI practitioners all over the world across enterprises much, much easier. It's available in Python, Java, Scala under the Apache 2.0 license, so really easy to get started with. Now, let's look at how it works and how can it make your machine learning pipelines much, much simpler? Well, to start with, your pipeline demonstrated here is constantly flowing and crunching data. In some cases, you don't even keep a record of what data was processed yesterday or 5 minutes ago. The data is ephemeral. And when you're tasked with answering a question about your model or data behavior, you have to reproduce the entire data flow. It's really annoying. WhyLogs solves this problem by logging all key statistics of all of your data over intervals of time. So instead of reproducing stuff, you just load a log file from the past, the same way you debug typical software systems. Now, there are multiple open source libraries that tackle the problem of testing data quality, evaluating data drifts, packages like DQ, Great Expectations, and so on. WhyLogs takes a very, very different approach from those packages. What it does is it implements a standard format for representing a snapshot of data. This allows the user to decouple the process of producing data logs from the process of acting upon them. So WhyLogs provides a foundation for profiling, testing data quality, monitoring, and so on. Okay, let's get very concrete now. Here is how WhyLogs would work in your Python environment. You only need to run one line to profile and log everything. All of the statistics and schema, no configuration required. It should be as simple as that. It gets even better because you can log images and text. You can use the default configurations, or you can configure things to your liking and to your use cases. And you can tag logs to help you with lineage and so on. But for now, let's focus on this data frame. In this particular code example, I'm executing a logger to log a data frame. Let me show you in a really quick live demo of how easy it is to do. Now, as we all love live demos, let me switch a few things around. So what I have here is familiar to everybody collaboratory notebook. And I have installed the usual suspects that you would want to have in your machine learning environment. And along with them, I installed WhyLogs and imported it. Now what I'm doing is I'm grabbing a handful of batches from my system, exactly 7 days of data that my system has processed in the past. And I would like to see what was the data like over these 7 days. So I'm gonna run this trick really quick. Once the data is all loaded, what I'm doing is I am instantiating the WhyLogs app, and specifically, I would like to connect to the community edition of our WhyLabs platform that would load all these log files and help you visualize them. So and I'll be sharing a link on how to create an account here and so on afterwards in the Q&A. But for now, I'm jumping in here. I'm creating an access token, copying it over, and executing this line over here, all it's going to ask me to do is provide my org and then provide my API key. Woohoo, everything worked. So now what I'm doing is creating a few lines of very simple setup and then enumerating over these batches of data that I processed, that my system processed in the past 7 days. And I'm running this log data frame one-liner. Forgot to create a model, of course. So really quickly, let's set up a brand new model, give it a model ID of 3, and log some data. So the data is being logged as we speak, and this is all it takes to log all of the key information about each of the day's batch worth of data. Once this is done, I go back to the platform and I see our model 3 over here. I jump into it and really quickly want to show you a few things. So first of all, we processed 151 features over the course of 7 days, 7 batches of the past. And there's a lot of statistics that we captured about each one of the days. Specifically, can jump into one of the days that we captured, and it gives me a nice profile view, or it shows you all of the distributions of each of the features in this given day. It shows you all of the key statistics. You can really quickly start comparing one of the days to another, looking at the changes between the distribution, looking at any of the other statistical changes that are happening. And most importantly, now you can look at the entire 7-day window of data, specifically focusing on how did a particular feature change over time. In this case, I'm loading a feature called address state. It's a categorical feature. You can quickly see the distribution. If I jump into another feature that's called annual income, I can see the distribution of this continuous feature, looking at min and max, and then the full distribution, looking at missing values and so on. So it literally took me one line of code in order to really quickly ingest all of this statistics. And one key thing is no raw data left the premise. We only captured these statistical profiles that help us understand the schema, help us understand distributions and so on. It's as simple as that. Right, I'm gonna switch back to my presenter view and let's go continue with the presentation. Now, I'd love to answer any of the questions in the Q&A on how to get a hold of this platform, and would love to get your feedback on this specifically. All right, so now, as we discussed, the portability of this logger is really key. And you saw this one-liner experience that works with Python, and this one-liner experience is also available with your favorite tools out of the box. We build integrations to work with each one of these tools and make logging really a no-brainer. Another important thing is you need to run this very effectively in parallel with your main workloads. As you saw, I logged 7 days worth of data, 151 features per data frame with no configurations, and also really, really quickly live right here in front of you. WhyLabs is implemented to use stochastic streaming algorithms, which allow you to do all of the logging with one pass over the data. And if you're using systems like Spark, it is extra optimized to work with really massive volumes of data. And because we're able to process data really efficiently, we do not ever sample. We process 100% of your data, which means that we can capture very true non-parametric distribution, which is absolutely key if you're hunting for data drifts. All right, so going back to the initial conundrum of testing, monitoring, debugging, and documenting data, we developed WhyLabs initially to capture the data necessary for monitoring data quality and data drifts. But once we open sourced it, the AI community found additional ways of using the WhyLabs outputs. For example, you can use WhyLabs to test data. To do that, you generate a WhyLabs profile, and then you use that to extract constraints, and then you use these constraints in GitHub Actions. It's really elegant, and I'd love to connect with you and find new ideas for using WhyLabs. So to sum things up, more and more data science teams are using WhyLabs to enable operational machine learning activities the WhyLabs library integrates and is easy to plug into any Spark pipeline or any Python or Java environment. The majority of popular machine learning frameworks. By systematically capturing and storing log files, you can create a record of data quality and data distributions along the entire pipeline. This really enables a transparency and auditability in your whole pipeline. And by comparing log files from different places in your pipeline, you can build data unit tests, data quality monitoring, performance monitoring, and so on. This elegant open source library does not involve changing the architecture or the current workflow of your data setup. Just a few lines of code, and you will get powerful transparency to all of your AI applications and enable a wide range of machine learning operations activities. Check out the GitHub link to the WhyLabs package, try WhyLabs, and be amazed at how much easier it will make your day-to-day machine learning operations. And please send us feedback, contribute, help us extend this open source library, help us develop the open standard for data logging. Join the effort for building one today. Thank you.
Thank you so much, Alyssa, for that insightful talk and the amazing demo. So we do have time for some questions. So if you have any questions, please type in the chat and I will do my best to get into it. To start off with, is it possible? I guess you have the links there, so don't need to type it in chat. I'd love to, I guess, talk about one comment that you made early in the talk that I think was really great, which is if you are not keeping an eye on your model in production, your customers are, and I definitely agree with that. And it's something that, given nowadays where there are a lot more, I guess, news coverage on AI models and some of its short pitfalls or shortcomings, and it is something that companies do need to have a lot of emphasis on. So our first question is about, is this designed to be an addition to traditional logging, like Splunk, or as a replacement?
Absolutely designed to be complementary to the traditional logging that you would enable in your software systems. What WhyLabs captures in addition to the traditional logging is information that is specific to the data that your systems process. And WhyLabs is fully open source, so the data that you're capturing technically can go directly into Splunk or some other platform that you're using for monitoring and parsing your logs.
And I guess going back to the earlier, earlier point that you made about debugging and kind of addressing bugs in the production model, what sort of efficiencies have you kind of noticed with WhyLabs that, in terms of time frame of responding to these type of bugs for production models?
That's a fantastic question. Thank you for asking, Peter. I think most important efficiency that we observe with teams that start using something like WhyLabs is to have a very systematic approach to addressing issues as they come in and to debugging issues as they come in. Without a systematic way of logging what happened in your system an hour ago or yesterday, what you have to do is replay the whole thing or pull data from elsewhere, process it, and visualize it. And that tends to be really time consuming, anywhere from hours to days, in order to even start looking at the data that was processed to start root causing. If you have a log file, you just load it, and in a matter of minutes, you know exactly what has been happening. You can see whether there were surges in missing values, schema changes, outages in the data, or the data distribution has changed, and so on. So it boils down the debugging process from days to potentially minutes.
Wow, that's amazing, and yeah, that's really great, and something that would drive a lot of time savings for any of the teams. I guess talking about the history that's maintained, how much of the history would be maintained? Is this that is, how long back can we go and see the derived analysis for the log files?
Yeah, thank you for the question. And I see that it's Hassan asking. So one of the nifty aspects of WhyLabs, and I was very briefly showing this in my presentation, so I'll go back a few steps, is that the output is very, very small. So we're talking about potentially gigabytes of data that we processed, and the output is bound by the number of features that we captured and the types of statistics that we stored. And this is a really cool property because it allows you to then make a decision of how long you want to store this data for. And in some cases, because it's so lightweight, why not keep track of the entire year or even longer if you need to? Another important thing is that these log files only capture statistical properties of your data. So even if you're working with highly sensitive data, you are now able to store the distributions of this data for a really long time without making any complicated, data privacy decisions because no raw data is captured there. So to answer that more directly, it really depends on the use case. If your data is highly seasonal, it maybe is worth to store a nice chunk, potentially a year or even more, because if you're then trying to train anomaly detection and understand, how your data changes over time, you have enough of a window to look at.
That makes a lot of sense, and definitely related to the seasonality of the data and also, I guess, use case, right? I think that is all for the questions right now. Thank you so much, Alessya, for joining us today.
Thank you, Peter. It was a pleasure to be here, and thank you everybody in attendance. As I mentioned, would love to connect and get your feedback and collaborate with you on building WhyLabs. So get in touch.
Great day, everyone.